Good afternoon, everyone. It is Sunday, January 16th, 2022. Of course, I'm your meteorologist, Stephen DiMartino. This is a special video to discuss our upcoming winter storm. Now, here's how things are going to work. I'm going to go over some of the observations. We'll also touch on another storm possibly for next weekend, and I'm not doing that to forecast for it, but more so to show the differences in storm structure between this one and the next one, potentially. Of course, that storm's several days out. Things can change, but we'll just go over the differences because I think it's a good learning tool. Also, we'll discuss what I'm expecting with this forecast. We'll go over the forecast map and all that good stuff. But before we begin, please like, share, and subscribe. Hit that notification bell, all that good stuff, because it's a really nice thing to do for me and for the channel. So there you go. So this is our current boundary layer. Now, this morning when I was going out to the gym and nearly froze my butt off, it was around 9-10 degrees around central New Jersey. Now we're up to 25. Notice the winds are from the northeast right now. Very important because that's draining cold, dry air southward. So as a result, we have temperatures in the upper teens to lower 20s over the northern interior, lower to mid 20s in your suburbs, upper 20s in the New York City metro and the Philadelphia metro, upper 20s to lower 30s down towards southern New Jersey. Notice already Wildwood's up to 34, but the dew point's at 26. Winds are from the northeast here coming right off the ocean, so you can see the influence of the ocean. And you can see over the eastern Long Island in the upper 20s to lower 30s. So we start off with dry, cold air. So you might be wondering, okay, Stephen, how does this dry, cold air get driven out here? Because this, ahead of a storm, normally would be a pretty good sign. Well, let's talk about that. This is the oceans right now. In fact, here we are, zoomed in a little bit better. Here's our Gulf Stream, and then notice it's gotten pretty warm here around our coastal waters. Well, see, this is an issue here because now, if you get a northeasterly wind, hey, for a snowstorm, this is great because you draw moisture in, you keep the cold air coming in from New England. Here comes a major winter storm. You get plenty of snow, normally a 10-to-1 ratio type heavy wet snow in this scenario. However, when you start to have your winds veering to the east, guess what? That air mass source is no longer coming in from New England. It is now coming in from the Atlantic, which has very warm waters. So as a result, the low-level dynamics here, the low-level boundary layer, is rapidly warmed up once those winds go east. So once we see these winds go east, temperatures are going to spike. Or slowly, well, spike is probably a bad word, but you're going to notice the difference because before you know it, you're at 25, then you're going to be at 29, then the next hour you're going to be at 32, and then 34. Meanwhile, along the Delaware River Valley, this is where things get a little bit more tricky because, yes, you'll see that easterly wind, but the low-level cold air is going to put up a fight. So definitely watch out for ice, especially, let's say, over northwestern Connecticut, the Hudson River Valley, southern Hudson River Valley, northwestern New Jersey, say right around here, and just north and west of the Philadelphia metro and just north and west of Trenton here. I think you're going to see a nice little fight going on in the northwestern suburbs in Philadelphia with sleet and freezing rain before it goes over to rain. Meanwhile, up here, well, it's plenty cold. Now, this is from the SPC. And I want to show you this because it's really important to understand how does the storm go so far west. Now remember, when we started this a week ago, first the question was, hey, this storm's going to miss us, we don't have blocking, blah, 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 blah. Then it was, well, we're not sure yet because it could go further west and could go further east. Now we're pretty much locked in with a track basically cutting to the west of Philadelphia and heading up towards Albany. So how did we get to this point with blocking? Because the previous storm sets up the blocking for this storm so it doesn't, It isn't able to come up towards the St. Lawrence River Valley, but it's also not able to exit out in the Atlantic very easily. So how do we end up with this track? This shortwave right here instigates and enhances this trough here on the back side, okay? And starts to cause it to go into a more negative tilt. Now, the difference with this storm in this scenario is that it becomes vertically tilted. Vertically stacked, should I say. Why is that really important? Well, let's first look at the different levels. So we're at 300 millibars now, 500 millibars now, pretty much it's right over the 300 millibar upper level low. 700 millibars, pretty much the same thing. 850 millibars, almost the same thing. In fact, we'll go to a different map. Nearly the same thing. 925 millibars, nearly the same thing. And then all the way down to the surface, nearly the same thing. So how does this happen where you're seeing this jump towards the coast, but it ends up in here rather than out here? When a storm is vertically stacked, where all the low pressure systems are on top of each other, that is a point where the storm reaches its maximum strength and it can no longer strengthen much anymore. When that happens, the surface low is pulled further west, okay, because everything's kind of sitting on top of each other. In that scenario, that is how you get a low pressure system basically set up here. Now, normally when you have a 500 millibar low setting up around Pennsylvania and New Jersey, you're going to end up with a pretty impressive winter storm, as long as the storm isn't already vertically stacked, which is what this shortwave does to this storm. You see, because it's enhancing the backside of this upper level trough here, it causes everything to get stacked too quickly. And that is essentially going to be setting up by the time it gets to about Virginia later on this evening. So that's how you end up with a warmer storm, because what happens is that your 850 millibar low is forced to track up towards Philadelphia. And guess what this jet streak does? Well, what that does, I can pull it up here. All right, well, I'll just pull it up right now. Okay, so what that does is set this up for this evening. So this, around midnight, is driving into the coastal plain and driving warm air in and enhancing that easterly flow at the surface. Meanwhile, because it's gotten into a negative tilt faster and become vertically stacked, it forces this high pressure system to push east. So you originally had the block set up, but because it intensifies and basically goes through this life cycle too fast, it leads to this setup where we end up where we are, where we have snow changing to rain along the coast. So this jet streak here is going to be a really significant player in our forecast as we head into this evening. Because what this does is that it drives in a ton of moisture coming in from the Atlantic and all that warm air. It warms up the 850 millibar temperatures pretty nicely along the coast, changing any snow that we start to get at the initial phase here, changing over to rain. This also, though, leads to the threat for strong wind gusts and power outages. Why? Because some of these winds are going to be capable of getting mixed down to the surface, especially in some of your heavier downpours. And you're looking at winds, maxing somewhere around 50 to as high as 93 knots here. That's all focused right here, ladies and gentlemen. So when you have this type of jet streak showing up, it leads to several factors here. One, it enhances divergence and diffluence in the mid levels of the atmosphere. So what that does is it produces very heavy rainfall, which causes mixing, which allows these winds to get mixed down to the surface. But you also set up the potential with this strong easterly fetch to enhance coastal flooding, and also with the heavy rainfall on a still nearly frozen surface, it also opens up the potential for some significant flash flooding and urban flooding. So definitely be prepared for that. Coastal flooding, urban flooding, and also strong wind gusts. This is all basically around 10 p.m. to 3 a.m. Okay, in fact, by the time we get to 7 a.m. the next morning, this is lifting up into New England. We're starting to basically chill out from this storm and starting to get out of the worst of these conditions. Meanwhile, the same jet, which some model guidance was erroneously producing very warm outcomes, this jet also leads to divergence and diffluence here over northeastern Pennsylvania. And this is going to open up the potential for some strong mesoscale banding. That's how we keep the heavy snowfall forecast for locations like around Scranton, north of the Poconos, basically also the Catskills. So ski country up here, you're going to get walloped with a very heavy snowfall. Not everyone's going to see 12 inches. That's why I'm going with a 6 to 12 inch forecast, because outside of those heavy bands, you're going to get lighter snow, and also the potential that some mixing is going to occur around these bands, because with the sinking air, it also warms the mid levels of the atmosphere and the lower levels of the atmosphere, and we're already marginal. So as a result, you'll get wet snow with sleet mixing back over to heavy snow, back to snow and sleet, heavy snow as these bands rotate through. So that is what we're expecting here over the interior. Coastal plain, again, heavy rain. In between, well, this is where it's going to be a little bit more tricky. And let's use this guidance right here. This is the latest HRR guidance. I'm going to use the 16Z because 17Z is still coming out. And you can see the storm coming in there. And there's our initial snow. I would not be surprised if this is a little bit colder down towards Ocean and Monmouth County here, where we start off with a little bit sleet and rain, or snow, sleet, and rain. The snow for the coast, don't blink because you might miss it. That's why we're going basically a trace around there. But notice in here, we get some of these heavier bursts around Philadelphia, Trenton at the initial start here. And model guys is trying to figure out, okay, when does this transition rapidly over to ice? To rain, should I say. And this process right around here, around 8, 9 o'clock, don't be surprised if this is more sleet and freezing rain before it goes over to rain for about an hour or so. And then there's our shift. There's our warm air winning out. Still snowing very heavily over the interior. And then we start to see our pivot as our storm swings out. There's our wintry mix setting up, but also you get heavy snow bands at the same time. And then our storm continues to pull northward. By about 7 a.m., it clears the region and we start to calm down. We can also take a look at the European that is just coming out now. Let's see if we got that data. And it's basically showing the same thing. It's not as fine because you can't get the same type of resolution, but you get the basic idea here of what it's trying to show. And notice it's trying to keep that snow in the Poconos, because as this low pressure system jumps back towards the coast and starts to set up that secondary, it's going to start to try to keep that cold air in place. And then at the same time, you have a 700 millibar low, so look for dry sliding to cut down the precipitation before it has a chance to change over much. And then as the storm pulls away, you get your snow shower mix. So when we take a look at the winds in this scenario, and again, this is going to be coming in like a fire hose. So this is going to be some very intense heavy rainfall early tomorrow morning, should I say, as this marches its way through. But that same heavy precipitation is going to be frozen over the interior. Now we'll pull up the winds. And you see there's that easterly shift that starts to take place. And it drives right into the coastal plain. That's how we warm up our coastal plain. Very strong winds along the coast. In fact, let's pull up the wind gusts right here. See what that shows. And you can see there's our wind gusts starting to show up. And that lines up right with our low-level jet. So you have some pretty strong winds out here, pushing over 50. This is all in knots now, remember that. So we're definitely pushing over 50 miles per hour here as this low level jet's lifting through. So it's not going to be constant wind gusts, but it's basically going to be when this basically fire hose of rainfall lifts up along the coast. That's when we're going to see these strong wind gusts taking place. So we're talking again from about midnight through 4 a.m. here, just marching its way up the coast. And so that is where we set up our forecast. Now, I wanted to show a comparison between this storm, which is vertically stacked. All right, let's go from 18Z on down. Okay, you can see what happens as it becomes vertically stacked, especially over Virginia. It's all in one location. And so as a result, there's our warming that takes place, right? Now let's fast forward to, and then this is the 0Z guidance, to our next storm potentially for Saturday. Now, there is our upper level trough here, right? We have one with the polar jet stream, and then we have our subtropical short wave right here in the subtropical jet. So they're separated at this point, right? And so you get strong lifting taking place on Saturday morning. Saturday afternoon, there's our trough, there's our upper level low in the polar jet stream. This is a typical structure with these type of storms. But notice, with this setup, that the mid-level lows are far away from the upper level low that's out here. See, this is when you have the various structures of the atmosphere slanted towards the east. This is typically what happens with a winter storm. So typically when you have a strong upper level low over or to the west, you have all your other upper level lows and structures off to the east. And that's how you keep your snow band, your snow potential on the coast. Now, there's a lot of factors here with this solution. For one, this could easily become more phased here, and so this ends up further west, or it could miss it completely. So I wouldn't bank on this just yet, but certainly something to keep an eye on. So walking through our forecast again, along the coast, zone 5, looking at snow briefly, changing over to rain pretty quickly, trace a burst of snow and sleet followed by rain. Not looking for anything significant here, okay, in terms of snowfall. Watch out for urban flooding, flash flooding, and of course coastal flooding in these zones. Zone 4, this is where the cold air tries to hold on a little bit longer, looking for a trace to 2 inches of snow, some ice on this, maybe under 1/10 of an inch of ice though, not looking for significant amounts here. Again, trace to 2 inches of snow. Zone 3, this is where the cold air really starts to try to put up a fight, looking at 2 to 5 inches of snow. There's a good chance we're going to see more sleet out of this here in Zone 3 and also probably Zone 2. So the more sleet you see, the lower you're going to be more likely towards 2 inches than 5 inches. And then we change over to rain by around 1, 2 a.m. Again, very icy conditions here. I would not be surprised if we get around 1/10 of an inch of ice out of this. Zone 2 is the same scenario here. Snow mixing with sleet. The more sleet you get, you're more likely to be around 4 inches. Higher snowfall rate, you're more likely to be up to around 8 inches. Notice the bow here. This is kind of matching where the low-level jet kind of marches its way through, and where we get the heavier snowfall, that's where I'm placing the edge of that jet streak as it's marching northward. All right, so again, Zone 2, looking at 4 to 8 inches of snow. And then Zone 1, this is where you're going to see mostly snow, mixing over towards sleet towards the end, and a little bit of rain at the very, very end before the 700 millibar low cuts off the precipitation. Looking at 6 to 12 inches of snow. This is where you're going to have your banding. So like one town could get 6 inches, the next town is close to 10, 11, maybe even 12 inches of snow. This is heavy, wet snow. Okay, you're looking at snow ratios of 10 to 1 to 8 to 1 here, based on the influence of this jet streak dynamic. And again, here it is, it's setting up. We're going to be watching it march its way northward as we go on through the day. And just to pick up on the interaction between the cold air mass that's in place, positions are high as this all pushes in. So we'll be having coverage on this and keeping an eye on this all the way through this evening, of course, while I'm watching my football games and other things. So we're going to be keeping an eye on this. Definitely follow on Twitter, as I will have constant updates. And, of course, for all you premium members, we will be having live coverage as well on the chat room if you have any questions. That's it for today. Have a wonderful day, and as always, stay safe out there.